Okay, I'm going to go over how to determine conjugate acids and conjugate bases. But first, let's look at some terminology. An acid, a Bronsted-Lowry acid, is considered a proton donor. Proton in the form of a hydrogen ion. So that means an acid's going to give away its hydrogen. And a base is a proton acceptor. So that means a base is going to accept hydrogens. Right, so now we have something called conjugates. A conjugate base is a substance that is produced after an acid has donated its proton. So in our example here, it says HF is our acid. Well, if our acid's going to donate its proton, what's left over? That would be fluorine. So fluorine is considered our conjugate base. In this example, water is a base. So what happens to water? It actually gains this hydrogen from HF. So if it gains a hydrogen, it is now a conjugate acid. So keep these definitions in mind as I go through the next few examples. All right, rewrite each equation. Identify the acid, the base, the conjugate acid, and the conjugate base in each of these equations. All right, so since I'm not doing mine on the worksheet, I'm just going to label them. I'm not going to rewrite them out. So number 1, HCl, hydrochloric acid. So we learned how to name acids back in chapter 7. So if you need to, flip back to chapter 7 and look at how to determine what an acid is. So HCl is our acid. That makes H2O our base. You have to be careful with water. Water is called amphoteric. So that means it can act as an acid or a base. So it just depends on what you're mixing it with. All right, so a conjugate base is what's left after an acid has donated its proton. After HCl has donated this hydrogen, what's left? Take over a look. It's chlorine. So chlorine is considered our conjugate base. A conjugate acid is a substance formed when the base accepts a hydrogen. So H2O, if it accepts a hydrogen, will become H3O+. So H3O+ is now our conjugate acid. Okay, let's look at number 2, NH3 plus H2O. If you've taken notes over chapter 14, section 1, there are two different set of tables. One is a table of acids and one is a table of bases. NH3 is ammonia, which is a weak base. Do not get it confused with NH4+, which is called ammonium. So NH3 is a weak base, so I'm going to label it as a B. So in this example, that means H2O is an acid. Right? NH4+, we've gone from NH3 to NH4. It gained a hydrogen. If it gains a hydrogen, it's a conjugate acid. H2O is now OH minus. It lost a hydrogen, so it's a conjugate base. All right, so that's pretty straightforward. Let's look down at number 4. It gets a little bit different, but not harder. So now instead of working with ions, everything is some kind of compound. We still do them the same way. So H2SO4, that's sulfuric acid. So that makes NH4OH, ammonium hydroxide, as our base. So our acid, it donates these hydrogen. It gets rid of them. So what's left over? Well, this right here, ammonium sulfate. So if it's what's left over from an acid, it's a conjugate base. Well, what happened to our base? Well, we lose this, our sulfate. We have OH minus, and what does it do? It gains this hydrogen from our acid. And if OH gains a hydrogen, it becomes H2O, which would be labeled as our conjugate acid. All right, so now you should be able to finish the rest of 1 through 8. So let's go down and look at the chart. We work these the same way, but instead of writing it out, we're just filling it in the chart. So acid, HClO4, it donates its proton. So what's left? Whatever's left is our conjugate base. So ClO4 If it lost a hydrogen, that means it lost a positive charge. So ClO4 is now a -1. You have to put those charges on there. All right, our base, we have ammonia again. Our base is going to gain a hydrogen to form a conjugate acid. So instead of NH3, we have NH4. If it gained a hydrogen, it gained a plus charge, a +1 charge, so it should be NH4 plus. So our products should always match up with our conjugate acids and conjugate bases. On number 10, you're taking your acids and bases and your conjugates and writing out an equation. So make sure the acids and bases are your reactants and the conjugates are your products. On 11, you're going to do the opposite. You're going to take your reactants and decide which one's the acid and which one's the base. And then you're going to take your products and you're going to decide which one is the conjugate acid and the conjugate base. So you'll use these 4 substances to fill in the 4 boxes. Number 12 is kind of tricky because now we have to think about it backwards. We're given the conjugates, but we have to figure out what was our acid and what was our base. So if a conjugate base has lost its hydrogen from its acid, SO4 with a -2 charge is our conjugate base. It lost a hydrogen, so we need to give it its hydrogen back to make it an acid. So we're going to come over here and put HSO4. It was a -2, but now it's gained a hydrogen. It's gained a +1, so a -2 and a +1 gives us a +1 charge. And then conjugate acids. Conjugate acids have gained a hydrogen from their base. So to take this back to its basic form, we need to take away a hydrogen from our conjugate acid. So this just becomes H2O. So now you're going to use those 4 to write your equation. 13, 14, 15, same thing that you've done on 9, 10, and 11. On 16 through 18, you are writing out equations. So just like this last column, just like these, you're going to write out equations for each one of those for whatever substances they give you. And that should be it.